Great to be here, Paul.
Yeah, good to be with you. We always like to demo to each other, so
This would be scary.
might as well do it here.
We brought a whopping one slide. So we are not slideware people. For folks that don't know, I'm Scott Hunter. I've been at Microsoft 17 years, a lot of time in .NET, currently in Azure. On the Azure Developer Experience team, we build things like App Service, Azure Functions, Azure Container Apps. We build all of the VS Code tooling for Azure, the VS tooling for Azure, and the SDKs.
SDKs, yeah.
I've got Paul here. I'll let you introduce yourself.
Hey there, I'm Paul Yuknovich. Also work on Azure Dev Experience. I'm the product lead for serverless, and I work on microservices and cool open source projects like DAPR. I'm a contributor.
So,
Yeah.
with that, we just thought we'd just kind of hack on a couple things today. Number one, we're going to talk about Redis. So since this is the Azure talk for .NET Conf, we're all Azure here, so we're going to talk about Redis Cache. There's some great capabilities we've added in .NET 8 for Redis Cache. I assume everybody's seen Aspire a couple times by now. We're going to show how you can actually take an Aspire app and publish it to Azure Container Apps using our Azure Developer CLI. And then Paul, as you said before, he works on something called DAPR, which is the Distributed Application Runtime. Some folks earlier today kind of thought Aspire and DAPR might compete with each other, but they're very different. Aspire is a .NET mechanism for writing .NET applications, and DAPR is more of an abstraction of things like storage, messaging, and so on. Yep. Great for running an app local, running it in the cloud, swapping out components without having to change your code at all. And it works great with Aspire. And so we're going to demo some of that. I know Maria and Louis already did a little bit of AI. I might do a quick recap of some of that. And then we're going to show how, in just a few lines of Azure Functions, you can do some amazing things with OpenAI. And then one of the most exciting things for me is we actually built functions on .NET. The actual runtime of functions has been .NET for forever, but it never has had like native ASP.NET feel. It's always been this thing that's kind of its own set of APIs. And so for the first time ever, you're going to be able to use ASP syntax, ASP model binding as part of your Azure Function apps. And I'm really excited about that. And then finally, the last thing is functions can scale like crazy.
Yeah, what's that about?
What's that about?
Yeah,
and
love to see that.
So we're just going to jump around and do a couple of these things, and we'll see where we land, and hopefully get some questions.
All right.
So with that, so Redis Cache. So Redis Cache is something we've had in Azure for a long time. One of the nice things about Redis Cache is it's an open source cache implementation, which means it's not tied to Azure, it's not tied to Microsoft, it's not tied to anything. And .NET 8, we made some great improvements in our caching. So we've had this feature called output caching in .NET for forever. I think all the way back even to web forms. And the idea behind output caching is you have a page in your application, and you might generate that making some database calls or some API calls or something else. And with output caching, what you can say is, I want to cache that page for this amount of time. Or I want to cache it until the URL changes. Maybe there's an ID for a product, and you can say cache it until that ID changes, and then we'll generate that new page and cache that page. There's a whole bunch of ways that you can dial this. Now what's new in .NET 8 is for the first time ever we have Redis support for output caching. And so I've got a little app here. It's not super complicated. It's not super crazy. And you can see in my main startup here, I actually add the builder services, add output cache. I didn't put any properties there, but I could set up policies and a bunch of other things. And now I've got this new thing, which is builder.services.add stack exchange Redis output cache. And this means I'm going to actually connect my output cache to my Redis in the cloud or on my local machine. And you can see here builder.configuration. All this does is it's going to go look at my app settings.json. It's going to go find the connection strings for my Redis cache. That's all you've got to do is basically give a single connection string to Redis, and you're ready to go. And then down here, a little bit lower, you're going to see that I've actually added a app.use output cache. I learned last night, super important to put that one after the routing. Doesn't work before the routing. I will have to talk to the .NET team saying, would it be great if these things actually told you when you put them in the wrong place? And so After that, all I've got to do, I've got 2 pages. I've got a cached page. I'll do a non-cached page first. My non-cached page, not crazy, just a regular page, but I've added one thing to it. I have a thread sleep 2000, so it basically is going to pause for 2 seconds every time it generates the page. It's going to be slow. And then I've got a cached page. And all I've done on the cached page, as you can see, I brought in a namespace so I can get the attribute, and then I added an attribute to the page. In this case, I'm doing a simple thing. I'm not looking at varying by parameter or anything like that. I'm just saying output cache for 10 seconds. And so once I'm done with that, when the page generates, it's good for 10 seconds. And just like the non-cache page, if I go look at the code behind here, I've got that same thread sleep 2000. So let's run this. So this is not a fancy app by any means. Here I am. I've got my 2 pages. If I go to not cached, you can see it does the circle for a couple of seconds while it's waiting. That's that 2-second delay. If I go to the cache page, the first time I hit it, it's going to have that delay. But now I can keep hitting it, and you can see the cache is full in effect. And so one of the greatest ways of saving money in the cloud is actually caching stuff in your application. And so output caching makes it very easy to take any page that you're generating with the database and store it in a Redis cache. And I know that our Aspire samples show caching as well, but I showed this purposely because if you've not moved your .NET application to Aspire, you can use this now in production. It's ready to go with .NET 8. So with that, we can jump back over here, Paul, and let's talk about Aspire plus AZD. So I'm assuming everybody's seen Aspire. Aspire is the new cloud-native framework or programming model inside of .NET 8 for building your cloud-native applications. I'm just going to go to a link here, aka.ms/AZD. And it's going to talk about the Azure Developer CLI. You might ask, what is this? So if you've been using Azure in the past, we have a Azure command line interface called AZ. And AZ is what you would do if you want to manually create an app service or manually create a Redis cache. If you want to go query some of the stuff that you have in Azure already. But it's very manual. If you're going to run a bunch of these AZ commands to do something.
It's good for little ops tasks. Right?
Yeah, it's great. I mean, it actually is more of an ops thing than a developer thing.
Yep.
Azure Developer CLI is something that's different than that, and I'll explain that. So we had a problem a couple years ago when we would have developers that would go and try one of our samples, and the first thing they would run into is the GitHub repo would say, run these 25 AZ commands. And if you messed any of them up, well, you better know how to go erase that and start over again. And so the first iteration of AZD, Azure Developer CLI, was written so we could go put some special folders inside of a sample that would tell us how to go provision and make that app run inside of Azure. Now with .NET 8, we're releasing a new build of AZD that knows about .NET Aspire. And so what it means is you can take any Aspire application and run AZD on it, and it will let you publish that application to Azure. The cool thing about the Aspire apps is they actually generate what we call a manifest, which describes the flow of the app. Here's all the components that make up the application, and all AZD does is scans the folder of your Aspire application, finds that manifest, and then it's going to go generate the assets required to actually make this work in Azure. So let's try this. So I'm going to go over here and I never found a use for Start Window, but it's great for flipping between apps. And and so I've got this is basically your default Aspire app. There's nothing fancy here. It is got the Redis cache. It's got all those things going in it, and we can Control F5 it just to show that it works. There's nothing special I've done here. And I'm going to do the thing that's crazy to do on stage, which is I'm going to actually publish an app while we're sitting here, Paul.
Oh, heck yeah.
What could go wrong?
Don't you have to write a few thousand lines of bicep or ARM or something?
I think so. There's a bunch of that stuff you have to write.
All right.
I just want to show that the app runs first, and then we'll go run some AZD commands. And then while it's publishing, I'm going to show some other aspects of AZD that we can do here. And I will say my machine is not the fastest today. I've only installed like 35 preview builds and so on over the last couple of months.
It's kind of the hand-in-the-box stress test.
Yes. And so one of the fun things for any of us that work at Microsoft is like after this day's over, I'm going to pave my box. So here's the app. It's running. You can see here it's got a container. It's got Redis. It's got the front end and the back end. Nothing special. Now let's drop back down here. I'll stop the app. And let's go jump in that folder in my command prompt. So I'm in the .NET Conf Aspire app folder here. There's the app. And I'm going to run azd init. So init is what you actually do to have azd kind of learn about your project. And so it's going to go, do you want to select a template, like grab something from GitHub? Or would you like to just run and see if I can scan the current folder? I'm going to say yes, let's scan the current folder. And it's going to go look through that all the folders I have here and find the manifest that describes the application. Let's give it a second here. There's lots of
I remember,
files.
that's super simple. Just like this service, this dependency, that's it.
That's it.
Yeah.
And so it's like, hey, I found an Aspire application, a .NET Aspire application, and do you want me to generate the necessary files? I'm going to say, yep. And now it's asking me, hey, I found two services. I found a front end and a back end. Which of those do you want to make available to the internet? In my case, I want the web front end to be on the internet, so I'm going to go and click that on. And it wants an environment name, so I'll say CSH Aspire. I'm going to say 10 because I don't know how many of these I've done. And so that's going to be the resource group. Now it's created a few files, and we're going to go jump in those files in a second. It created an Azure YAML and a next steps. Now, the next step for me, honestly, is going to be just to run azd up. And so azd up is the command that says, once you've generated the right files, azd up will go and provision all the stuff in Azure for me. So let's go do azd up. And it's going to ask me a couple of questions. It's initializing the bicep provider. For folks that don't know, bicep is the language of how you describe your assets inside of Azure. I'll select my subscription that I want to use. And I'm going to select East US. And this is going to start running. So, and this takes about 5 minutes. But while we're waiting for that, let's go back to VS, and I'll use my fancy switcher here. And this is another application, and we'll just open another tab in my command prompt, and we'll go over to that folder. And over here, I feel like I don't want to go look at the stuff while this thing is running, Paul. I just want to do it in another folder to make sure we don't blow our feet off. And so what I'm going to do is basically do the same thing. I'm going to go do an azd init, and then we're going to go look at the files that azd creates. So this time I'm not going to do the azd up. I'm just going to go generate the files. We'll launch VS Code, and we'll see what actually has been done for me.
I've written a lot of those files, so I'm already appreciating this thing. Well, what am I going to do with all my time?
Paul knows this. Whenever I'm doing a demo, I call Paul at 11 p.m. the night before the demo, and I'm like, hey, I need 1,000 lines of bicep. Can you please do that for me? OK. So it's created those files. Now let's launch VS Code and see what actually happened here. So first off, there's an Azure YAML. And so this is kind of the description of my actual application. You can see it's got my Aspire app synth. It's got an app. It's written in .NET. It's pointing to my host project. That's if you watch any of the things that we have, that's the orchestrator project that actually boots up the rest of your applications, whether it's your Redis cache, local, your front end, your back end, so on. And that's actually all it's generated. If I go and there's also a magic Azure directory, and it's going to have a few things. It's those questions that here's the name that I gave it inside of the tool. Here is the exposed services. This is saying we want to expose that front end. So basically, all those questions I got answered got saved in this folder. If I go over here, you can see that my default environment. So nothing really fancy. But what's cool here is I can also open this next steps. And so when you do an AZD on a Aspire application, we generate this markup file that you can go look at. that tells you a bunch of things like, hey, I'm doing a raw publish right from command line. I might want to do CI/CD. And so we show you right here what changes you need to make if you want to actually add CI/CD to the flow. And so it's very easy to start with AZD manually publishing, but you can also turn on GitHub Actions or Azure Pipelines very, very easily. So let's keep scrolling in here. And it kind of talks about what was added. It talks about that Azure YAML that we talked about before. But this is even more interesting. I'm going to run AZD infra synth. And so what actually happens behind the covers today is we actually generate a lot more than what I showed you. We generate a bunch of stuff in memory, we run it, and then we throw it away when we're done. So the idea is we don't really want to go mess with your project unless you really care about seeing the assets that we actually create.
It's more like a library or something. Just use it.
So we'll go back in here, and this time I'm going to run AZD infra synth. And so what that's going to do is basically generate on disk the raw files that make all this magic work. Synthesizing infrastructure. And so while we're doing that, we can go over here and take a look and make sure things are good. You can see it's created a resource group, a container registry, log analytics, a container app environment. It created a cache inside the container app environment, and now it's making magic over there. So let's go back into our VS Code, and now there's going to be a little bit more stuff that we can go look at. So let's go look into one of our applications. Well, first off, there's this infra folder, Paul, and here's your friend Bicep.
That's my favorite.
And you're going to notice this has got just some raw descriptions, like the name of the environment. These are basically variables that are being declared. The location, you can see resource group, some Bicep stuff, some environment variables are put out there. I can go look at this file and see a couple more things. But over here, this is going to be where we actually see that real container app environment is what I would say. And so if I scroll through here, you can see there's a container registry. There's some authorization roles.
Actually, yeah, they're using managed identity, which is great.
Yep, it's doing all the right. This is doing best practice.
Monitoring, that's the stuff that you really need to do.
Operational insights here. This is our environment. Here's our container app. And so this is the raw bits that kind of work. Now, it creates this at the root, which kind of describes the thing we're going to go shove all the stuff into. And then each of these projects is going to have a manifest folder, which contains, this is the tech that we templatized to actually make each component. So this is my API service, and you can see target ports, HTTP, you can see the registry, the containers. So AZD will take those parameters we saw at the root level, shove those all in as templates, and then run this and inject it into Azure.
So it's got a lot better building blocks now.
A lot better building blocks. And we made this command where you can generate this, so in case you want to go modify some of this stuff yourself, you're welcome to as well. And so that's all the stuff that's generated. I'm going to guess, if I go back over here and look, you can see we've actually now deployed the app to the cloud. I can control click on the endpoint. You now see that I am not running on my local machine. I've got Azure Container Apps.io as my endpoint here, and this is all good. I want to show one more quick thing about how this works, real quick, and let's go switch back. This is my favorite switcher mechanism. We'll switch back to the Aspire app, and you might ask the question. This is great. I got started. What if I add something new? So let's go add another project. So I'll go to my solution. I will say add new project. We can do a web API. And my new API. And I can ignore most of this, but I notice there's a checkbox here in list in Azure Aspire orchestration. This means when I click that, it's going to automatically wire this up into my infrastructure. And I'll show that. So My new API project is here. If I go to my app host and go into program.cs, you're going to find that it's going to have added, here it is, my new API. And if you've seen this before in any of the Aspire demos today, I can go up here. I could give it a variable like this, var, and I can say new API equals that. And then for my front end, I could decide, hey, I want to make sure that the front end also has access to that new API. Oops. How good are we on time? We're good. So I'll give you about 20 minutes. Is that good?
Sounds good.
Okay. Okay, so if I build this, all I've done now is take that away. If I build this, I can go back and I can run AZD up again. And let's go do that. And what it's going to do now is it's going to actually go and notice that I added a new container, and it's going to go add that container to my container app environment and publish the app.
No way.
And of course, it failed. Dun, 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 dun. Let's just double check to make sure I didn't break the app. I broke the app, Paul. Oh,
You did.
no.
In fact, everything's broken. It's all squiggly.
It's all squiggly already, so it was squiggly before.
It happens to the best of us.
Oh, why did it break? Because I have this twice.
Wow.
It's got to be real. So,
It doesn't like to repeat itself.
well, you can't have two of the same things.
No, it's physics.
Physics don't work.
No.
So I just wanted to prove to everybody it's real. This is not scripted.
Yeah, keeping it
There
real.
it goes, running.
Nice.
And we're going. And while we're waiting for this, I'm going to switch one more time and talk a little bit about, there's this great blog post that I think I have it here, that Stephen Tobe wrote and the team. It's about using retrieval augmented generation, or RAG is what we kind of call it. Mm-hmm. He has a whole bunch of samples using semantic kernel and .NET. I've got this cool project that I wrote that took all the samples that he has and kind of merged them together into a single thing. And I'm going to run one of those or two of those. Let's not show those things. Those are bad.
We'll be rotating those.
delete the entire thing. So basically, this is just an app that has all of the code that he wrote as samples. And so it starts off with a simple GTP. I'll run one of these.
Loving all the terminal today. Feeling at home.
I feel like I'm on my Mac.
Yep.
And so I just asked a question. This is ChatGPT in like 3 or 4 lines of code. And you'll see here, there's a date time example. That's where you actually have it call some .NET code to answer a question. There's memory where we keep a history of all the things you're chatting. There's memory for streaming that makes it give that nice chat interface that you would see. And then it gets really cool with what we call memory plus embedding. And that's where I want to be able to ask it questions about Stephen Tobe's blog post.
Yep.
And in that case, the buffer I'm allowed to use is only so big. And so my only option is to basically run this version of this. And I'll scroll and show you the code, and then we'll flip over to Paul's machine. I'll go down here. And now you're seeing that it's not simply as easy as it was before. I create my in-memory thing. I go and grab his blog post. I go loop it and chunk it up into paragraphs so I can break it into smaller chunks. There's a lot more code here. And then you get to my questions. And what was 4 or 5 lines at the top now is like
Hundreds.
100 lines.
Yeah.
And when you run it, you're going to notice that doing all that work is a little complicated. And I'm not going to go all the way through it. We're just going to switch to you. It's going to start chunking each paragraph in. And it goes super slow right now because I actually am rate limited because I'm using a small subscription.
And it's Stephen's blog.
And it's Stephen's blog, and you all know
just way too much
they only take like
yeah.
3 hours to read, so it's going to take like 20 minutes to put into the
Yeah.
embeddings. But I want to flip to you.
Okay.
We built this really cool tech I guess I skipped twice because you have a DAPR thing and we have
That's
this.
okay. We can go to AI.
Let's go to AI first
We'll
and
roll
go
with
to
that.
DAPR.
All right, perfect. If you want to switch over to
We're
me.
going to switch to Paul's laptop now.
I'll get my bearings. So, all right. So yeah, Scott was showing the RAG scenario, and the way I think about it in Paul speak is just we're going to chat our data. This is the easiest way to do that. So there's really two steps. You want to get your data in and ingest it. And as Scott was showing, the trick to that is you've got to turn it into embeddings, and I'll talk about that in just a second, and then upload those so that the semantic search can find it, and then you can do your semantic search. You can basically prompt over it. So one of the things we felt like has been a real struggle talking to the community out there is actually doing that embedding process. And I saw you writing for each and all kinds of algorithms to chunk over it.
Splitting stuff and knowing all kinds of crazy stuff.
So we have, it's experimental, it's a binding, but it's public because functions is open source and it's extensible. So we have a couple attributes that we think will make your life better. First one, we have this embeddings attribute, or embeddings binding, I should say. And that'll just let you take in file as a file path, as a hunk, eventually whole folders, OneDrives, all those kinds of things. But you could just point it at your data. And that's all you have to do to actually suck that data in and turn it into the embeddings, which is what the machine wants. And then the second thing is we have a semantic search binding. And as you'd expect, it'll look at that same data source and let you either upload data in or retrieve the data out. So now the whole code, just to ingest all the data, turns into just this. Basically 3 bindings and 3 lines of code, where the main part is that we're going to take the output from the binding, and we're going to pass in a searchable document.
So we took 100 lines of code and really took it to 3 lines of code and a bunch of attributes that kind of describe how things bind together.
And it's using managed identity, and it's making it nice for us, right? So we don't, no connection strings.
Can customers use this today, or is this something they can?
Right now, yeah. So right now the bindings are live. They're actually NuGet packages. As you said, it's written in .NET. So the NuGet packages are live. Look for OpenAI by Chris Gillum, and it's posted as him. And then our plan is to evolve this into a real Azure Functions set of bindings. But it's all there now. We're using the same extensibility that users do.
Should I expect to see this maybe at build next year?
Don't be surprised.
Okay.
There'll be a lot more. Yep, you should.
People can try it today and experiment
Try
with
it today. Tell us what you like and don't like. And here's the thing. I'm going to show you one way to chunk it. We're learning with you what's the right way to embed and chunk. So we need your feedback, but yeah, we're going to turn this thing into something awesome.
Basically, I fire my document into the function, and all that stuff that I wrote that 100 lines of code for is just happening for me.
Yeah, and let's check out the perf. And then part 2, I'll show you, we could just have another function that's going to do a semantic search and just retrieve the data right back out.
Awesome.
Okay, so what did I do? I took Stephen Toob's blog also, and it's interesting to have a line count, Scott. It's like over 10 grand. Lines of code. That's pretty serious, or lines of text. And so let's run the function. So we can do a func start. I could have 5, whatever makes you happy. And this thing's going to run. And we've also, I don't know about you, I don't like typing a bunch of characters into curl. So I'm really kind of fond of these HTTP files and the extension for REST.
I love these things too.
Okay, perfect.
And this is an extension you install into VS Code that will run these files.
Yes.
Yeah.
Yeah, and this is a clone restore run, so you can take this kind of quick start, and we've already got an ingest data function, or a little microservice almost, and then a prompt data. And so we're just going to fire off. First thing we're going to do is train the AI, right? So we're going to pass in our own data, and it's going to upload and do the embeddings. And if we pay attention, so we got a OK, this is live TV, right? And we can see that it did the embeddings. Now this is the part I like to look at, and a light bulb went off for me when I first saw this. So I'm here. This is Azure Data Explorer, aka Kusto. Really handy for getting data in and out quickly. And if we do a query, we can actually see, and I'll make this a little bigger.
And these are all the vectors that were created by the embedding.
Exactly. All the chunks and the vectors were passed in. And you can see first we see the text. And then Scott said, yeah, look at, these are the actual vectors that help, with weighting and help the machine understand the context between the words, and which is an underpinning of how this stuff all works.
So when you actually put a question into like ChatGPT, it then can look at these embeddings to figure out which of this text is the right text to actually put in the buffer as it thinks of your results.
And it happens so fast. Yours was chunking for a bit.
I'm
not making fun of your code.
You probably have a better subscription than I do. So.
Yeah, that's got to be it. Better hardware. It's my new laptop. That's what it's going to be. But just to show you, this thing, thanks to the vector database, it's actually shredding through the embeddings and uploading them, ingesting it that fast. Okay, so I just delete it. Now we'll query again. Now we can see the embeddings are there. So this is real. Like, it's really putting it in. And now let's go ask a question. Okay, I had kind of a softball. How do I put embeddings data into a prompt? But tell me in the style of someone who's ready to celebrate. All right, well, I have no idea what's going to happen. All right, and we'll send the request. All right, it's getting pretty colorful, but it's a little saucy, but it's
good.
It's doing the actual work. But the whole point of this is just two bindings. You can ingest the data. You can do your secure, private, compliant queries over it.
So to me, I just think of this as if you want to go add AI to your application, you take your data, not the public internet data, shove it in, and then you can easily ask questions against it in just
perfect
20 lines of code. I think this is super exciting,
and functions like a good companion, right? So you might have existing apps, and now you can make it an intelligent app just by adding a function to it.
So let's show some DAPR.
DAPR, all right, I love DAPR too.
So as I mentioned earlier, DAPR is the Distributed Application Runtime, and I know from feedback we got this morning on the keynote that some people thought that Aspire and DAPR might be these competing technologies, and I don't think of it that way at all. DAPR
I
is
don't
meant
either.
to be,
and I was talking to the maintainers and the founders today, and we were all having a great chat about it. Sorry, I didn't mean to cut you off.
No, that's great. We were just chatting about this before, that he actually did talk to the founder today, because they were asking the same question, like, what is this?
Yeah, but we come to the conclusion, actually when I look at Aspire, there's so many underpinnings from TIE, and you might have talked about that, but just the wonderful tooling and the ability to bring in dependencies and extensions and orchestrate all the parts of my app. It's helping with that part. And then DAPR, I look at, like the website says, a set of APIs or building blocks to do best practices. And it's got these abstractions with a whole bunch of implementations behind it. So, DAPR really will help you build that app. And Aspire will help you integrate it super well into .NET.
I think it's cool that how easy you can actually add DAPR to a .NET app. It means it just makes it's like you add a component, and you're ready to go. And my scenario that I think about is, hey, I'm developing locally, maybe I'm using RabbitMQ on my local machine. When I go to Azure, I want to use Service Bus. If you build the app using DAPR, I don't have to change my code, even though I just changed the implementations of the messaging completely. DAPR abstracts that thing away. So DAPR is an abstraction on many of the core concepts that we have. It makes your app more portable, makes local development easier, and it does some of the same things Aspire does. It does some of the retry logic automatically for you. And you might ask, well, I'm a .NET person, why does that matter? Well, what if you call a Java API, or a Java API calls you?
Or an external API, or a non-Aspire, right?
Exactly.
It helps you really ubiquitously, hit things. And I think, talking about APIs, we haven't even explained. So PubSub is a really good example. I want to send messages, have guarantees, have time to live. Just in one-liners, DAPR can do that. And then you get the resiliency. We use MTLS, mutual security by default. So there's just so many things kind of built in. So it does some heavy lifting. So that's DAPR.
And day zero, we're making it available in Aspire preview.
And it's a real integration.
It's really, really good.
So building on what Scott said. So I took, there's a repo out there right now called Aspire-samples off of .NET. And so I was playing with that and having some good fun. And so I took, let's remember this. So git checkout main. Okay, so the sample will show you how we can do an implementation of the web Razor pages so that when you call an API, you're going to get the weather back. In this case, the Aspire app is actually using DAPR APIs to call DAPR-based microservices. So if you have microservices out there, this is showing you how easy it is to fold those in and integrate them. And as you can see, one of the cool things that this even does by default, we could call an API by name, and it's going to do the service discovery, and it's going to do that secure MTLS connection. So already I'm getting some advantages with that. Another thing that I'd love to show is Aspire has a really nice way to bring in the dependencies. So in this case, it's not directly a Redis cache. I'm bringing in a microservice, like the API microservice, which is based on DAPR. And Aspire made that really easy. And notice, like, for those of you who use DAPR, you kind of know, hey, I have to DAPR run to start a sidecar, pass in 100,000 parameters, and then at some point you've got it going. So that was always a bit of friction. It's really nice to see .NET has actually kind of eliminated that friction.
Yes, the hosting tech in Aspire just makes that so easy to run.
And then, but wait, Scott, there's more. I got to show you a little more. So let's take the more custom code, DAPR state. So I wanted to show that, teeny bit more realistic example would be that I want to do a little bit of state management, right? Because I'm calling these microservices, which are hitting databases and servers. As much as we love to blame the DBA and the database people, it's not actually always their fault if you're not using caching or you're not using state management.
Earlier today,
That's right.
So let's cache. We should cache the weather as well.
Exactly. So in this case, what I'm actually going to do is look in a state store, or think of it like a cache. And actually, this is backed by Redis cache. And I'm going to get the state out of that first. And if that doesn't exist, we're going to go ahead and call the microservice. And in that case where we do a cache miss and we first load the data, let's go save that and actually put it in the Redis cache. And even like I mentioned the best practices. So, DAPR is going to give me guarantees. I can even set a time to live, right? So just all of these things I'm able to do in like one-liners and passing a few parameters. And like Scott said too, this is an abstraction. So if I want to use Redis, if I want to use Dynamo, if I want to use Cosmos DB, Blob Storage, all these kind of different backends.
And you can use Redis locally, and when you deploy your app to Azure, you can use something else, and your app doesn't change.
Actually, if you want to geek out a little bit, literally that's exactly what I'm doing. So when you install the DAPR CLI, it gives you Zipkin, and it gives you, I'm sorry folks on this resolution, it's a little crazy. Somewhere there's Redis. Can you see it?
You can do a Control Plus or.
Oh yeah, I could. You've become the command line expert. Oh, there it is, DAPR Redis. So yeah, the DAPR CLI kind of fulfills dependencies automatically with Redis cache as a container. DAPR doesn't need containers, but we'll use Redis to be your pub sub, to be your state store. It'll help with workflow, which is a cool new API. But anyway, so here we go. So we've got this app, and instead of like DAPR run infinity, we're going to do. All right, Scott, I'm going to listen to you for a change. So .NET, and that's the command I was looking for, .NET run project app host, because that's kind of our orchestrator project.
App host is the project.
Is that what I call it? Orchestrator project?
That's what I call it. I don't know what the .NET folks call it, but to me it's the orchestrator because it actually boots up all the other side projects.
And what did I break? I'm in the wrong folder, Scott.
Typically you want to be in the root folder or the host folder.
There we go.
That looks better.
I like that.
There should be a URL in there somewhere, which is the dashboard.
All right, so let's try this. So we're gonna run the Aspire project. This is a trick we've actually done for a long time to have a kind of a host project. All right, so now we can, like Scott said, we can open the dashboard. It's not expecting that. Oh, that was silly. I went to the dashboard URL, so let's do this one. Aha! Okay, so here are my two microservices, my front end and my back end.
What does containers have?
Yeah. This one?
Or just containers, so there should be a container tab up there.
Oh, I see.
Right there.
Yeah, no containers found. So this is the cool thing. I'm running this to the metal, right? And then, because we're just doing this locally, now let's go to the web app. And here we go, fast cache response. And the other thing, all the things you've seen today, the observability, the retries, that's kind of in there. And so, just to summarize, you can use the power of DAPR together with Aspire, very complementary.
Yes.
And since we heard so many questions, I felt like
I think it's important to show that these
it.
things actually complement each other. They don't compete with each other.
Okay, so we've done Aspire, DAPR.
We have native ASP.NET Functions or Flex consumption. I think we should do native ASP.NET because that is something that's been so long in the making that for folks who don't know, for Azure Functions, about a year ago we started this project to start making all of them look like the native app. So if you're a Node person, you want it to look like Express. And we finally have gotten to .NET, and so now we're making .NET projects look like .NET.
We actually made changes. Let me just go ahead and revert that. All right. I thought we'd do a little before and after.
I want to see a before and after. What does it look like today or yesterday?
Today, well, we could really learn Azure functions. All right, so today, you're going to see some things. Let's get started, C#.
I always think of today what you do is your response comes in and you basically have to go parse the JSON to go grab the parameters out. If you're used to using .NET for a while, we do model binding where we just map the parameters to parameters on your function, and I really want that. And on the way back out, in .NET, it's an iAction result. You just return your type back to that, and we automatically do the JSON serialization for you. So you're getting model binding on the way in and model binding on the way out. And if you look at a classic function, you do that code by hand.
You do, and you have some different, I mean, they're good .NET types, but they're not the ones we're used to.
They're not the ones I'm used to in ASP.NET.
From like 6, 7, 8, ASP.NET, we're not used to this anymore. So HTTP response data, what is that, right? So, so here in this project, and I'll give you just a sec to come over there, doing things out of order. You know, it's good, it's keeping me on my toes. And .NET, HTTP. All right, so here's, I think, the exact same thing you saw where it's async, but we're seeing that type we didn't expect. So that's kind of the before. And these functions are real simple. It's an HTTP trigger, so that'll be like either a webhook or just a simple web API. Make a get, make a post, and return it. Now let's do the after. All right. And we got some new look and feel. Look how much the code reduced.
There's all my .NET things. All the things I natively feel with .NET. This is my
first thing, you own main. You own main again. Like,
yes.
It's just like a real...
It feels like a minimal API .NET app.
Minimal API. Here's your iAction result, return result. Here's the real HTTP request. And also, so that was the get. If we look at the post, now I can take advantage of great features like from body, so I can deserialize into a real person object.
It's a real person object for me.
Just with a record. So like, already, I mean, this is real ASP.NET, and you get DI. You can bring your own middlewares, you own main.
As a .NET developer using functions, this is the most exciting thing I've seen in, honestly, forever.
Okay, that's pretty awesome. Well,
so we have almost 3 minutes left. Can we do flex consumption in 2 minutes, 3 minutes?
Yeah, we can. No pressure. All right, so flex consumption. Flex consumption, you're going to hear a lot about tomorrow. It's basically the consumption edition of functions we've always wanted. That's got the real corporate networking. It's got all the SKU sizes you want, like how much CPU, how much memory, either really small, really big. Actually, while I'm blabbering, let's start a load test.
You should kick a load test off.
Because
so isn't that one of the things with functions? It's been one of the challenges of functions over the years. Has been if I actually throw a bunch of load at it, it takes it a while to spin up to handle that load, right?
It does. Like it could take 8 minutes, let's say, to start batching up more instances to handle the load. So we've always had a good scale controller that's kind of good at monitoring, but to actually produce the number of workers you need has been tricky.
So how much faster is that with flex consumption?
Yeah, I've seen some runs, whether it's HTTP or queue based, that could be more like 1,000 instances in under a minute. And that's what we're doing now. We're not done, right? So
think about that. That means your app starts as a single instance, and a big pile of work comes into it, and it goes from a single instance to 1,000 instances in roughly a minute. And then as soon as that work falls off, it starts scaling all the way back down, right?
That's right. Yeah, exactly right. And it can scale in just as quick. I mean, we have some cooldown and some configuration in there, but the whole idea is, you spend the money when you need to, and then you release the resources and stop. So it's a really great. I mean, this year we're all thinking about being efficient. It's really going to help with that. Now, what I'm doing now is I'm racing a load test, Scott, which is like it's got its own cold start that we have to think about. So how about I explain a little bit about flex consumption, just kind of how it works. So, one of the things is that in today's consumption SKU, we actually had a bit of polling so that the scale controller that's monitoring HTTP in your queue, it's kind of like actually pinging and polling your workers, which wasn't super efficient. So that's a better algorithm. Also, functions now understand concurrency, which would be like, how big of a batch do I want to support per instance to do execution? So now it understands concurrency, and the scale controllers and the workers work together to coordinate, and plus the compute itself is so much faster.
So we have 20 seconds left, Paul. So
This is gambling, Scott. I mean, like, is it? Are we going to see the live metrics in time?
While that's waiting for that, just flip back to me real quick on the slides, and I just want to go do a recap. We've showed Redis output caching, how easy you can do that. Any .NET app. We've showed how AZD makes it easy to take an Aspire app and publish it to the Azure. We've got DAPR, which now works side by side with Aspire. We've got great AI support in functions, native .NET, ASP.NET, Azure functions. And we'll flip back to Paul and see if in the last 0 seconds we can actually show the scale up.
Oh, and look at that. Look at that curve. And in the time, like even I had nothing, now we're up to 28 servers doing 1K per second. I mean, this thing, we can get up to 60 real easy. So anyway, that's what you got to look forward to. We're going to start talking about an early access preview tomorrow.
Awesome. So that was a whole bunch of .NET and Azure. .NET and Azure work awesome together, and can't wait to get feedback from you trying all these new tools. Thank you.
Thank you.